Hello.
Kita na po.
Okay. Okay, so thank you po. So let's start po the discussions about po the non-destructive testing. So we are done po with destructive testing, so which is we need to destroy the materials in order to determine their properties. So right now po, yan. So ang i-discuss naman natin is about non-destructive testing. So for this module, uh, we have three intended learning outcomes. So the first one is to differentiate the types of non-destructive testing. So we have po four types po of non-destructive testing na i-discuss ko po sa inyo. So we have po the magnetic particle inspections. Another one po is the ultrasonic testing. Pangatlo po is the liquid penetrant, and the last part po is the radiographic testing. And then for the ILO number 2 is to describe the basic principles in conducting non-destructive tests. And the last part is to determine the type of test to be used in order to identify the defects of the materials. So not all types po of materials is applicable for every non-destructive testing. So there is a specific materials lang po na pwede nating i-test sa different types of test na gagamit, different types of non-destructive testing. Okay. So we have here po three pictures. So these pictures po is about conducting po yung ating non-destructive. So sample picture po ito, sample illustrations on how to conduct a non-destructive testing. So the first one on the left side is the ultrasonic testing, so which use the sound waves in order to determine the defect of the materials. And another one po on the right side, this is what we call po the radiographic testing. It is just like an X-ray po. When we do X-ray yan sa ating katawan, so ganun lang din po yung ating radiographic testing. And the last part po is what we call po the dye penetrant testing. Okay? So which use po the ultraviolet radiations in order to visibly to see po yung ating to see the defect of to clearly see the defect of the material. Okay. So before we discuss po the different types of tests, so now we have to define muna what is or to determine what is non-destructive testing. So when we say non-destructive testing, it is a wide group of analysis techniques so used in science and industry to evaluate the properties of the materials, yan, the components or system without causing damage. So the main purpose of this non-destructive testing is to test the materials without damage. So we can use it again po. So kahit iti-test natin siya, so magagamit pa po natin siya. Ano po? So, wala dapat damage. No damage dapat dun sa ating materials. This is one part po of the functions of quality control and is complementary to other long-established methods. So, every company has its, ano po, what we call po the quality assurance or the quality control na, na area na kung saan po tinitest natin yung quality of the materials. Ano po? Quality of their products. So that is why po they use non-destructive testing kasi hindi nila pwedeng sirain yung material. So iti-test natin individually yung material. So iba-iba po yung property niya individually. Okay? So it depends po dun sa ano po natin. It de- dapat dapat po hindi walang mababago din sa material natin kapag tinest po natin siya. And then the last one is it is the testing of materials. So for surface or internal flaws or metallurgical conditions without interfering in any way with the integrity of the materials of it or its suitability for surface. So we can determine po the internal flaws, but we can also determine the surface flaws of the materials. So without po causing damage. Okay? So this is the reason for conducting non-destructive testing. So the first reason that kung bakit natin ginagawa ang non-destructive testing is that the materials is not destroyed. So hindi dapat i-destroy po yung materials. And then we need to determine po the internal flaws of the materials and also useful for valuable components. Yan. So ito po yung mga outputs po natin and then products. We just want to determine its quality. So na hindi dapat talaga siya masisira. So very useful po ang non-destructive testing dun sa mga hindi dapat po masira. And the last one can test components that are in use. Even though po the material is already installed, so we can inspect po the quality of the material. Okay? So we have here po the common types. So we have four types of non-destructive testing. So we have the magnetic particle inspections, ultrasonic testing, penetrant testing, and the last one is radiographic testing. So iisa-isahin po natin ay discuss itong mga different types of non-destructive testing po. So the first one is the magnetic particle inspections. So these inspections po is suitable for the detections of the surface and the subsurface or near subsurface po discontinuities in magnetic material. So meaning this test po is only applicable to the magnetic material. The non-magnetic materials po is not suitable for this type of test. Ano po? So commonly, ferritic steel and irons po is the materials to be used. Ano po? So this method is used to inspect a variety of products, forms such as casting, forging, and weldments. So after po the process of casting, forging, and weldments, so in order to test po or to identify or to determine the quality of the output for after ng casting, forging, and weldments, so we can use po this type of test. Okay? So if we want to determine if there is a crack, ano po, surface crack in the surface, or um, meron siyang other discontinuities like the pores, surface porosity. Yan. So, madidetermine natin using the magnetic particle inspections. Yan. So, many industries use this type of test in order to inspect ano pa, yung ating mga material that's already installed. And one of the reason of their inspecting po the materials is to determine if the components fitness for use. So, tinitingnan if pwede pa pong gamitin yung components na naka-install. And then, some example of industries that use the magnetic particle inspections are the structural steel. We have the automotive, the petrochemical, power generations, and the aerospace industries. So sila po lahat yung mga gumagamit po ng or gumagamit ng ganito pong type of test. Also, the underwater inspections can be done using po the magnetic particle inspections. So we can check po the offshore structures and the underwater pipelines. So para alam natin if pwede na if need pa nating paltan or meron dapat tayong gawin para hindi siya mag-cause ng leakage lang, lalo na yung ating mga underwater pipelines. So this is the common use equipments po for the magnetic particle inspections. So the first one is the stationary magnetic particle examination system setup. So ito po yung setup natin kapag siya ay permanently. So it uses po the wet fluorescent particles in order to determine the crack of the material. So gumagamit din ito ng ultraviolet lights, and we have here po the source of the magnet. So this one is the source of the magnet. We will magnetize po the material. Yeah, so in this type of inspections. So they use wet fluorescent particles And then this one, this is portable magnetic particle inspection equipment. So wherein they use po the AC yoke as a source of the magnetic field and use the dry powder po Yan. So to see clearly po the defects in the material. Okay? So this is the procedure in conducting po the magnetic particle inspection. So the first one is that we need to do is to clean the surface to be examined. So we can use po a different types of materials for cleaning the surface like the detergent, the organic solvent, the scaling solutions, so the paint removers, before degreasing, sand or grit blasting, or ultrasonic cleaning methods. So the main purpose po of this cleaning is to remove the impurities, the dirt, and the other po na nandito sa ating pong material na i-examine. So after cleaning, so next that we need the next step that we need to do is to introduce a magnetic field into the part. So using po the ACU, yan. So ito yung ginagamit natin as a source po of the na magbibigay ng magnetic field dun sa ating material. Yan. So, by the way, this non-destructive testing po is only performed po by the expert, expert, expert technicians po. So, there is required trainings before you conduct po this type of test. Yan. Dapat certified ka, before mag-perform ka ng ganitong test. Okay, so after introducing the magnetic field into the part, the next thing, the third step po is to apply the ferromagnetic medium. Yan, sabi, while the part is still magnetized. So maglalagay tayo dito ng ferromagnetic medium. Okay, so and then after applying the ferromagnetic medium, the next one is to remove the excess, ferromagnetic medium using po the light airstream from the bulb, syringe, and other source of low pressure dry air. So, dahan-dahan lang po. Kailangan mahina lang po yung pag-apply natin ng pressure. Dapat mahina lang yung pressure ng air na gagamitin natin in order to remove the excess ferromagnetic medium. So, and then the number 5 is after po yung the removing the ferromagnetic medium, so you can see po in which part kung saan nandun nanatili. Dun po nandun pa rin yung ating ferromagnetic medium. So meaning po, if there is a ferromagnetic medium that exists po in the material, so therefore, meron siyang defects dun sa material na to. So after natin na removing the excess ferromagnetic medium, the next thing that we need to do po is to interpret and evaluate yan any indications of the applicable acceptance standards. Yan. So that is why po hindi tayo basta-basta pwedeng mag-perform na ganitong type of test kasi hindi natin alam if on how we interpret this figure or through visually how can we interpret yung ating magiging result. So only experienced technicians po can do that po. They do the interpretations and they need to evaluate po if these cracks po can cause damage to the material. Po. And then after interpreting, the next po is we need to test po the other part po of the sample. That is why po, when sabi dito, turn the yoke 90 degrees from the original positions and then repeat steps 2 to 5 po. And then after po, magawa natin, matapos natin yung buong part na to, so we need to clean the material po and demagnetize, sabi dito, if necessary. So this is the procedure po on how to perform the magnetic particle inspections. This is for for AC yoke with dry powder. Okay? So what is the advantages po of using the magnetic particle inspections? So the first one is they can find both surface and near subsurface defects. So meaning po, yung surface lang, yung pinakaibabaw lang at konting malapit lang po din sa ibabaw, kaya po niyang i-detect yung mga defects. And then another po It can use po na portable, and it is low-cost type of ano po, inspections. And then the results can be rapidly determined. Meron tayong immediate results. And then next po, indications are visible to the inspector directly on the specimen surface. So kita na po agad ng inspector kung saan po merong defects po yung ating material. And this one po can detect defects that had been smeared over. And the last one is can inspect po with irregular shape. Yan. Irregular shape po, pwede pong i-determine natin yung defects. So, using po this material. So, the disadvantages naman, so, the main disadvantages po of this type of test is that the specimen to be used should be ferromagnetic. So, is mga steel and cast iron lang. And then, if there is a paint po greater than or thicker than 0.005, so it must be removed before po tayo mag-inspect, before the inspections. Okay? And then, plus cleaning and post-demagnetizations is often necessary. And ang depth ng sensitivity niya is typically 0.1 inches po. So, this is the reason why only experienced technicians can do that inspections po, because the alignment yan, between the magnetic flux and the defect is important. If tayo, hindi natin alam kung saan dapat ilalagay siya, so hindi natin siya ma-examine ng ayos. That is why po, we need the training and the certifications in order to perform this type of test. Okay? Did you understand po? Hello? Nagpuputol-putol po ba ako?
Hindi po.
Okay, did you understand?
Opo.
Okay, so this is the applications po of the magnetic particles inspections wherein they perform the MDT po in ano po, sa mga planta, sa mga field po. So this one, this ACU quid powder po is the portable type of equipments used for determining the inspections of the magnetic particle inspections po. So ito yung portable. Yung isa kasi yung nakaset up. So this one, so they examine po the longitudinal seam on the in-service boiler. So kalimitan may mga weld po yung mga yan. So we need to determine if okay pa yung quality of the weld, kung hindi pa po siya nasira or wala pa siyang defects po. Kung pwede pa siyang gamitin kasi since it is boiler, so it has a high pressure po inside. So that is why we need to um, ensure po that the weld po ay hindi po masisira. Ano po. And then this one is the empty examinations of the lifting lug weld on the in-service boiler. And another po is steam drum. And then this one, it is the results po from the empty test that we can see that there is a crack po, in the steam drum. And ito po yung ating video for the magnetic particle inspections. Yan. Naririnig niyo po ba?
Opo.
Okay.
Hi, my name is Mike Porter. I'm a corporate NDT level 3 for Alta Vista Solutions. And this is part of a video training session where we're going to be performing magnetic particle testing on a painted component. So what we're going to do is we're going to demonstrate the proper technique to perform magnetic particle testing through a layer of paint on the component. Typical applications from ASTM E709 is a particular standard that we're working to, the American Standard for Testing of Materials. And it doesn't allow you to test through paint. You need to test through uncoated surface. You're allowed 1 or 2 mils of paint, and that would be acceptable. But if it's a special application like this particular component has about 16 mils of paint on it. So in order to test through this, you need to be able to demonstrate that you can find the particular anomalies that you're looking for and demonstrate the technique. So This is a magnetic particle yoke. We're going to start over here. One of the things that we teach our technicians is the proper technique to apply the particles. As you apply the particles, you want to actually just float them on. You don't want to dump them on with a can such as that. You just want to be able to lightly float the particles on. Same thing with the pumper. When you blow the particles away, you want to be a little tender and a little sensitive and make sure that you have the right technique. We're going to move down across the plate, making sure that we have overlap. So I make sure that I test 100% of this particular component. I don't see anything there. I'm going to move down again. And as I apply this here, we actually start to see the formation of an indication along the toe of the well. That happens to be about a 2-inch long crack in the heat affected zone. So as I talked about before, that it's important to know the techniques and the proper technique of blowing the particles off. Because if I use too much force, especially on a painted plate as opposed to an unpainted plate, I can actually blow the particles away and you no longer see the crack. So again, it's important to have the proper technique in floating the particles on and watching them form, and also the proper particle removal with blowing. So this completes this particular video training session on performing magnetic particle testing on a component that has a layer of paint. Thanks, and have a great day.
Okay, so yan po yung ating using po the dry materials, using the AC yoke with dry powder. And another one po is using naman, okay, another one po is about po yung using the fluorescent fluorescent light po, using the wet fluorescent particles in order to determine po the defects of the material.
Non-destructive testing, magnetic particle inspection. The magnetic particle examination is an excellent method to investigate near-surface defects in ferromagnetic materials. This video shows the basic principle and the practical procedure. The material tester gets the machine ready for use and inserts the test piece between the two poles of an electromagnet. Then she takes a bottle with a suspension of magnetic particles, turns on the electromagnet with the switch, and applies the suspension of magnetic particles onto the test piece. Already in daylight, dark lines are visible on the surface. The lines can be seen much better under ultraviolet light, and particularly well at darkening the daylight. The suspension contains pigments that cover the magnetic particles and fluoresce under ultraviolet light. Particles run off in areas free from defects, and they are attracted and clustered near defects. This workpiece shows a whole array of cracks. The basic principle is to magnetize a ferromagnetic workpiece parallel to its surface, as shown in the sectional view. If the workpiece is free from defects, the magnetic field lines run within the workpiece and parallel to its surface. In places of magnetic inhomogeneity, for instance near cracks, the magnetic field lines will locally leave the surface and a leakage field occurs. Now, if a suspension of ferromagnetic particles is applied onto the test piece surface, the magnetic particles will run off at defect-free areas. In places of leakage fields, the magnetic particles are attracted and clustered together, thus indicating the place of the defect. The method works best using a pigment which covers the magnetic particles and shows fluorescence under ultraviolet light. Even cracks can be detected that are not open to the surface but just below it, as long as they are not too far below the surface. But one precondition must always be fulfilled. The magnetic field lines must be perpendicular, or at least at a certain angle to the defect. Otherwise, there will be no leakage field and the defects remain undetected. Our test sample has been magnetized in horizontal direction. The magnetic field lines run horizontally. This is the reason why cracks in vertical direction are visible particularly well. To make sure to detect all near-surface cracks, one has to magnetize the sample once more and best perpendicularly to the first time. To do this, the material tester switches the machine over to the current flow method. A high electric current flows through the sample, generating a circular magnetic field. Now the cracks in horizontal direction can be seen very well. The tested sample is a hardened sliding guide. The cracks have been formed during the hardening process and the subsequent grinding operation. Still, another test piece has to face the magnetic particle inspection, a section of a large gear wheel. The same procedure again. Placing the gear wheel between the magnetic pole pieces, magnetizing and applying magnetic particle suspension. Already in daylight, there are indications of cracks, and again, they are best visible under ultraviolet light while darkening the daylight. The visible cracks are so-called fatigue cracks. They have been generated during the operation of the gear drive due to the mismatch of the gear wheels.
Okay po. So, yun po yung ating magnetic particle inspections. So, the next type of inspections po is the ultrasonic testing. So, this type of test naman po or inspections is used for the detections of the internal and the surface defects po. So, it use sound waves po in detecting the defects po of the materials. Yeah. So, in this type of test po, so we use very short, yan, sabi dito, in UT or ultrasonics, so very short ultrasonic pulse waves with center frequencies ranging from 0.1 to 15 megahertz and occasionally up to 50 megahertz are launched into the materials to detect the internal flaws or to characterize materials. Yan. So a common type of example is the ultrasonic thickness measurement, so which tests the thickness of its object. So for example, to monitor pipe port corrosions. So in this type of test po, we are using a sound waves po. Sound waves, yung wavelength po niya. So just like po in this example, so we have here po, this is the normal wavelength po for this po. Yan, dito sa una natin. But this one is meron tayong na-detect na flaws. So since bumalik po siya agad, ano po? So after traveling po, yan. So bumalik agad yung ating sounds, yung ating wavelength. So meaning there is a flaws po dun sa part na yon. Okay? So another this one po is the normal probe. So we are using here po the normal probe, and this one, so we are using naman po the angle probe. So meaning po, so nandito yung ating part, dito natin nilagay yung surface, but the detections po is in another surface. Okay? So this type of test po can measure the thickness of the material. So just like this po, yung ating travel of the sounds can be converted into a distance. So that is why po, we can determine po the thickness of the material. Naintindihan ka po? Did you understand it po?
Opo, ma'am.
Yan. So if the material po is lumiit, for example, lumiit yung kanyang diameter, so mabilis po nababalik yung ating pulse wave. Ano po, magkakaroon siya ng nagbabak na po agad siya. So makikita natin, ano po, So, makikita natin if may flaws po dun sa part na yan. Okay? Yan. So, this material po is very efficient or very useful po, especially if the material po is in ano na po, is in naka-install na. So one of the inspections that we that that we can use po in order if the pipe is pwede pa siyang gamitin or not. So, we can use po this type of test po, the ultrasonic. So, malalaman naman natin kung lumiliit na po yung kanyang thickness. So, if there is a decrease in terms of the thickness in the pipeline, so therefore, there is a corrosions in the pipework. Okay? So, this is the sample equipments used for the ultrasonic testing. It is just like an ultrasound po if the girl po is ano. So, para lang po siyang ultrasound. And makikita natin the defect po using po this. Kasi ito yung normal natin na wavelength. And then this one po, kapag may fault po, so mas maliit po yung kanyang wavelength. Okay? So how does it work? Okay, so we have two types of equipments used in ultrasonic testing. The first one is yung normal natin na ginagamit. So sabi dito, meron kasi tayong gumagamit ng couplant and another po na couplant is not required. So sabi dito, in ultrasonic testing, an ultrasound transducer connected to a diagnostic machine is passed over the object being inspected. So the transducer is typically separated from the test object by a couplant. Yan. So kapag wala kasing couplant, hindi siya gagana. Dapat separated ang ating material na iti-test and the transducer. Ano po? Kapag walang couplant, hindi siya. Ito yung normal na this is the normal, yung normal na ultrasonic testing machine. So, the couplant po may be oil or pwede siyang water or, yun, nagkakaroon tayo ng immersion. So, ini-immerse daw po natin. However, meron tayong another type of ultrasonic testing machines that use po, that yung hindi po gumagamit na ng couplant. Hindi required yung magamit ng couplant, so which is the electromagnetic acoustic transducer. And then we have two methods daw po in receiving the ultrasound waveform. So the first one is the reflections and another one is the attenuations. Yan. So in reflections po, so yung atin pong transducer or yung ating probe, so sabi dito, siya yung nag-performs both the sending and the receiving of the pulse wave. Yan. So, sabi dito, as the sound is reflected back to the device. So, reflected ultrasound comes from the interface, such as the back wall of the object or from the imperfections within the objects. So, the diagnostic machine displays these results in the form of the signal with the amplitude representing the intensity of the reflections and the distance representing the arrival time of the reflections. So, ganun po yung nangyayari kapag siya ay reflection. So, dun sa mismong part, so, iti-test po natin yung specimen natin dun sa surface and then magte-travel po yung sounds and then babalik. Magte-travel yung sounds, babalik. And pag meron po siya nakita na discontinuities, so, bumabalik po siya agad. Ano po, dun sa part ng makikita natin, malalaman natin kung saang part, hanggang saang depth, nandun po yung ating, nandun yung defects because of yung travel ng ating sounds. Okay? So, it is different naman in attenuations because it is through transmissions naman siya. So, dito, the transmitter sends the ultrasound to one surface. And then, meron tayong another po, yan, a separate receiver. So, sa una po, sa reflections, so, siya po ay sending and receiving po ay isa ang ginagawa po ng transducer. But this one po, so ang transmitter po, siya yung nagsisend ng ultrasounds sa isang surface. And then, a separate receiver naman po, yung nagdi-detect, yan, sabi dito, and a separate receiver detects the amount that has reached in it on another surface after traveling through the medium. So sa ibang surface naman po natin, nakikita, yan, or nare-receive yung pong defect. So parang yung sa angle probe po. So doon natin siya, dito po, yan. So dito natin siya tinitingnan. Pero yung defect po, nandun po sa other surface. Yung nade-detect po niya is sa other surface po. And then, ito po yung mga advantages of using the ultrasonic testing. So, the first one po is high penetrating power. So, kahit po dun sa pinakababa, sabi dito, which allow the detections of plus depth in the part. Yan. So, kahit yung pinakababa po, pwede po niyang ma-determine yung kanyang flaws. Ano po? So, kahit sa pinakababaan po. So, ma-determine niya yung flaws. And then, high sensitivity. So, kahit small flaws po, kaya niyang i-detect. And then, we just only need one surface po to examine the whole material. Isa lang pong surface pwede natin gamitin para malaman na natin yung defect po ng buong material na yon. Yan. So, it is greater accuracy than other non-destructive testing method. And then, it is capable po of estimating the size, the orientation, and the shape, and the nature of defects ng ating material. And then, next po is, siya po is non-hazardous. Ano po? So, very, safe po sa ating mga personnel and no effect po dun sa ating materials. And the last one, it can be, portable or highly automated operations. So, for the disadvantages naman, so, just like what I said po, so, we need a careful attention po by the experienced technicians. So, experienced technicians lang po yung makakapag interpret po ng totoo dun sa atin pong Kasi minsan, meron pong noise, yan, hindi natin maiiwasan. So, pwede po siyang maka-effect dun sa atin pong sound waves po. So, that is why po. So, alam ng experienced technicians if yun ay noise or po. Yan. And then, next po, extensive technical knowledge is required for the development of the inspections procedure. And then, this is not applicable po. It is difficult to inspect po if the material po is rough, irregular in shape, and then very small or thin, and not homogeneous. So, medyo hindi applicable po yung this type of test sa mga ganito. And then, so the surface must be prepared by cleaning and removing the loose scale, paint, etc. So, same lang din naman po din sa ating magnetic particles. So, kailangan din po na cleaning. So, kailangan naman talaga natin linisin. And one of the disadvantage niya is we use po the coolant. But, meron naman tayong materials, machines po na hindi na gumagamit ng coolant. And the last one po, dapat yung material na i-inspect natin, yan, sabi dito, inspected materials must be water resistant. So when using water-based couplants that do not contain rust inhibitors. So since we are using po the couplant, so the materials to be inspected should be water resistant po. Kasi if hindi po siya water resistant, so it can damage po yung ating material. Sabi nga natin, hindi dapat natin siya madi-destroy. Kaya nga siya non-destructive testing. Okay. So this is the the video for the non-destructive testing for the ultrasonic examinations.
Non-destructive testing. Ultrasonic examination. The basic principle of ultrasonic testing of materials is the propagation and reflection of sound waves. As an example, a cylindrical workpiece is shown in the animation. The longitudinal section through the cylinder shows the position of the atoms extremely magnified and simplified as a single crystal. To begin with, a rigid, unyielding stop is attached to the right front end of the cylinder. At the left front end, a disc is installed. It will be used to transmit and receive sound waves. Pushing and pulling briefly at the disc causes a longitudinal sound wave to propagate through the cylinder. When the sound wave reaches the rigid stop at the right side, it is reflected and runs back towards the disc, which now serves as a receiver. A free end is also able to reflect a wave. In this case, however, the tensile side runs ahead in the reflected wave and finally deflects the receiver to the right. The reflected wave is even reflected again and actually travels for several times across the length of the cylinder, but this is not shown in the animation for the sake of simplicity. So if a sound wave is generated at one end of the workpiece, it will travel through the material with its speed of sound. At the free end of the workpiece, the sound wave is reflected and it returns to the transmitter, which then acts as a receiver. For ultrasonic testing of a workpiece, not a large transmitter is used in most cases, but a rather compact one, which generates a short ultrasonic pulse. At a place free from defects, the ultrasonic pulse travels to the right front end, also termed back wall. The pulse is reflected and recorded again as an echo. When the transmitter is moved a little downwards, the cavity reflects a part of the wave. That part arrives earlier at the transmitter than the rest of the sound wave. Even further downwards, the cavity reflects the complete ultrasonic pulse. For material testing, either the echo of a defect can be utilized, this is the pulse echo mode, or the phenomenon that hardly any sound waves pass through the imperfection. This is called the through transmission mode. In pulse echo mode, the transducer installed in a probe performs both the sending and the receiving of the ultrasonic pulse. On the computer monitor, intensity is being plotted upwards on the y-axis and the time towards the right. With the probe at a place free from defects, only two signals may be seen on the monitor: the transmission pulse and the echo resulting from the lower surface of the workpiece, termed back wall echo. Moving the probe towards the right leads to an additional echo created by the defect. Even further towards the right, only the defect echo is visible apart from the transmission pulse. In our laboratory, there's a green painted steel cylinder to be found. It contains artificial defects which are invisible from the outside. To track down the defects, the material tester uses the pulse echo method. This is how a typical probe looks like. Under the bright wear plate, a piezoelectric disc is installed. It can transmit and receive ultrasonic pulses. The computer operates the probe via a plug-in card and power electronics. On the monitor, the intensity is plotted upwards and the time is plotted to the right. After placing the probe on top of the cylinder, initially no echo at all may be seen on the monitor. The reason for this is the too small contact area between the probe and the workpiece. Only with the use of a gel, the so-called couplant, the ultrasonic pulses can get into the workpiece and can also go back to the probe. Now the back wall echo turns up on the monitor. The material tester spreads out the gel evenly on the top surface. That way she is able to examine the entire cylinder. Using the velocity of sound in the material, one can plot the calculated depth on the monitor to the right instead of time. A very useful feature. With the help of so-called trigger gates, which may be set on the echoes with a computer mouse, the depth of the defects can easily be read off at the lower left-hand corner of the monitor. The cylinder back wall lies at a depth of about 200 millimeters below the probe, so the cylinder has a height of 200 millimeters. And here we go. The material tester scans the upper front end of the cylinder with the probe and observes the monitor. A defect echo appears on the monitor. This defect is located in a depth of 130 millimeters below the surface. Another echo indicates a defect in a depth of 87 millimeters. The second smaller echo at 174 millimeters is caused by double reflection on the same imperfection. And these are the defects: a drill hole and a saw cut. Filled up near the surface and painted, they are not visible from the outside. The drill hole in a depth of 130 millimeters. The saw cut 87 millimeters below the surface. Trams are popular means of transport in Karlsruhe, southern Germany. The tram cars are not only cleaned regularly, but also tested thoroughly regular intervals by the transport company. On many other maintenance points, the ultrasonic examination of the wheel axles plays an important role. The tram enters the maintenance hall for inspection. Some of the tram cars have already been lifted up. That way the bogies can easily be detached, pushed forward, and examined carefully. This is one of the bogies jacked up to comfortable working height and prepared for ultrasonic inspection. Special attention is given to the wheel axle, among experts known as wheel set axle. It has been designed as a hollow axle. This saves weight and facilitates the ultrasonic examination. The material tester applies a suitable oil as a couplant into the bore of the axle. Now he takes a special probe designed exactly for this purpose, inserts it carefully into the bore with a mount, and evenly spreads out the couplets by turning and pushing. He has accurately marked the most important examination points at the mount. In an experienced manner, he positions the probe at the appropriate places within the wheel set axle and watches the monitor closely. The probe has specially been designed for this application. It transmits the ultrasonic pulses at an angle of 45 degrees. At a place without defects, no defect echo returns. But when the pulse encounters a crack which has grown in from the outside, double reflection occurs and a typical defect echo is recorded. It is important to note that also the shape of the wheel set axle may lead to an echo, for example at shoulders. These are so-called contour echoes. In this particular case, only contour echoes are recorded. No abnormality has been detected. The wheel set axle is perfect and can be used again to transport many passengers until the next examination becomes due.
Okay, so that's all for ultrasonic examinations. And the next type of dye penetrant testing, the next the next type of non-destructive testing is the dye penetrant testing. So this type of test is used in order to determine the surface defect of the materials. So this one is the widely used ano po, type of inspections because of its low cost. Okay? So, mura lang siya. So, mas madali po siyang gawin. Ano po? So, this is applicable po to all materials, to all non-porous materials po, like metals, plastics, and ceramics. Ano po? So, it is applicable for the ferrous and non-ferrous metals. Diba? In the magnetic particle inspections, it is only applicable for ferrous metals. But this one, so it is applicable po for ferrous and non-ferrous. Okay? So the main purpose of this ano po, test is to examine the product of the product after ng ating casting, purging, and also yung mga wave weldments, ano po. And in order to detect po yung mga different types po ng defects like hairline cracks, surface porosity, and then we can also detect po if there is a leak in a new products, and also if there is a fatigue cracks on the in-service components. Yeah. So, dati, ginagamit po nila is kerosene, but ngayon po, we have what we call po the penetrant. Ano po? We have penetrant po, which is carefully formulated. Yan. So, to produce daw po the level of sensitivity desired by the inspector. So, meron na siyang mismong ginagamit po na penetrant. So, dati kasi, ah, is kerosene yung ginagamit. Pero ngayon, they develop po penetrant specifically used for this type of test. Okay. So we have two different types po of penetrant materials. So the first one is the fluorescent penetrant, and another one is the visible penetrant. Just like po in the magnetic particle inspections, they also use po the fluorescent lamp or the fluorescent light to visibly clear to clearly see po the the defects po of the materials. So on the first type po of the penetrant materials, which is the fluorescent penetrant, so it uses po a dye or several dyes that flourish when exposed to ultraviolet radiations. Ano po? So, meron pong gumagamit tayo ng ultraviolet lights and also required po yung ating dark room. So, while the visible penetrant so does not require darkened area, and also it does not require po the ultraviolet light. So in the visible penetrant, so commonly po the visible penetrant po contains of a red dye, and then it has a contrast between the developer background. Yan. So makikita niyo po mamaya if ano ba yung developer, ano ba yung penetrant, okay? So for the procedure of the dye penetrant testing, so the first thing that we need to do po is to clean the material. So in order to remove all the traces daw po of the foreign materials, grease, dirt, etc. And then after that is to apply a penetrant. So after cleaning, so we need to apply the penetrant, sabi dito, which is a very fine thin oil, usually dye bright red or ultraviolet fluorescence. So is applied, and then sabi dito, and allowed to remain in contact with the surface for approximately 15 minutes. So after 15 minutes po, the next thing that we need to do po is to remove po the excess penetrant. Sabi dito, the surface penetrant on the surface is then removed completely, and thin coating powder chalk is applied. So after removing po the excess penetrants, so we need to apply po the developer. So the developer po is the powdered chalk. Ano po? White powdered chalk. Yan. And then after several times, so we have what we call the development time. So sabi dito, the chalk draws the dye out of the crack, yan, rather like blotting paper. So to form a visual magnified in with indications in contrast to the background. So dito po, after sometimes na mailagay na po natin ang developer, and because of the good background, in contrast po din sa background, so mas makikita natin ng mas malaki yung atin pong crack or yung defects dun sa ating materials. So this penetrant testing, this penetrant inspections is only detect po the defects po on the surface of the material. Okay? So dun lang po yun. And then this one po is the sample illustrations. Yan. Yung kung paano. So first is we apply the penetrant, and then next is we remove po the excess penetrant using the water, and then after that is we apply the developer, and just wait for the development time, and then we can see po the defects po. So parang makikita talaga natin yung defects because of these two combinations, the white and the red. So the advantages po of the dye penetrant is it is simple to operate, and then it is best method to determine the defects po for the non-ferrous materials, or non-ferrous metals, and it is also suitable for the automatic testing, and it is quantitative. So the disadvantage po, so the main disadvantage of this type of inspections po, so it only detects po the surface defects. And then very minimum po yung kanyang sensitivity since ang nadidetect lang po niya na defects po is in the surface. And also, they use po the considerable amount of consumables. So, ang consumables natin is the penetrant and the developer po. So, this is the sample video po for the dye penetrant inspections. Okay, so yan po yung ating dye penetrant testing. So this is only for ano po, visible penetrant. So I forgot to download po the video for using po the uh, fluorescent penetrant po. So maybe later po. Okay, mapakikita ko na lang po sa inyo. And the last type po of the non-destructive testing is the radiographic testing. So in this type of test po, we use electromagnetic radiation in order to determine the defect of the materials. Okay? Sabi dito, it is a non-destructive testing methods of expecting materials for hidden flaws by using the ability of a short wavelength electromagnetic radiations to penetrate various materials. So this is a very dangerous type of inspections po because it involves radiations. Ano po? So most of the company that use this type of test po, so they separate po the area for this type of inspections. So because meron lang po siyang allowed na distance kung saan pwedeng pumunta yung ating mga workers. Ano po? So it is just like an X-ray po. And it is applicable to determine po the defects of the materials like ferrous and non-ferrous metals po and other materials, but only the internal part po. Internal defects only. Okay? So, only the internal defects. So, in the magnetic particle inspections po, so we detect po the defects in the surface and subsurface. For the ultrasonic, so it is surface and internal surface. So for the dye penetrant, so we detect po the defects in the surface, ano po, surface area only. While this one po, the radiographic testing is used to determine the defects naman po in the internal area naman po. So sa loob naman. Okay? So, sabi dito, X-ray generated electrically and gamma rays emitted from the radioactive isotopes are penetrating radiations which is differentially absorbed by the material through which it passes. And the greater the thickness of the materials, the greater the absorptions. So furthermore, the denser the material, so the greater the absorptions. That is why po nagiging kita natin pictorially yung results po ng ating test. So, using po the absorptions of the energy. Okay? So, this is the type po. This is example po of the source of the radiation. So, we have here po the radioactive. And then, this is the basic principle for the radiographic testing. So, we have here po a source of the radiations. This one is our sample to be examined. And the last one po is the film package. So there is a techniques that is needed po in order to set up or to place po yung ating specimen. So ganito yung nangyayari sa kanya. So from the source of radiations, so pupunta siya dito sa ating film package. So mako-convert po dito. So dito natin makikita kung saan po merong defects dun sa ating materials. Yan, unlike po dun sa ating this is the process film. Ano po? So unlike in our ultrasonic testing, so we can predict, we can determine po the depth kung saan nandun yung defect. But in this one, so hindi natin alam. We cannot say po na nandito sa part na to yung defects. So, ito lang siya. Ano po, makikita lang natin na doon sa tapat ng surface na yon, nandun po yung defects. Pero hindi natin alam kung gaano kalalim. Okay? So, ganun po yung kapag radiographic. Ano po? So, what's the advantages po of the radiographic? So, the main advantages po niya is the informations po is presented pictorially. So, kitang-kita natin siya. It can be a permanent record po. Can be with edit time. And then this one po, this type of test po is very useful if it is thin section. So, kapag maninipis lang. And then, sensitivity declared on each film and suitable for any material. So, we can use any materials po. So, the disadvantages naman is inability to cope with thick sections. So, katulad ng sinabi kanina, pang thin sections po siya. And then, next po is the possible health hazard. And then, sabi dito, need to direct the beam accurately for two-dimensional defects. And then, film processing and viewing facilities are necessary. Ano po? And it is not suitable for automations. It can, so it is not suitable for the surface defect because internal defects lang ang kaya niyang i-determine. And the depth po, yan sabi rin, no indications of depth of the defects below the surface. So, hindi natin makikita kung saan nandun talaga yung ano po, yung atin pong defects. Okay? So, this is the video po for the radiographic testing. So, in this video po, ipapakita sa inyo on how to place po yung ating, to set up po, yung magiging, tuturo sa inyo kung paano natin isa-set up before po tayo mag-conduct ng radiographic testing.
Using gamma ray radiation source. By using.
Sorry po, hindi pala po natanggal.
Ay, nalaman tapos na sa material.
Short video will show the method of radiographic testing inspection by using gamma ray radiation source. There are a lot of techniques of RT inspection. In this short video will show some of these techniques which inspect by using single wall single image technique, panoramic technique, double wall single image technique, double wall double image technique. The equipment and tools are gamma ray source system, radiographic films, cassettes, and intensifying screens, markers, IQ-line, penetrometers, weld specimen, magnetic stand, safety gear, exposure calculator. First of all, we'll show the inspection which is using single wall single image technique. This technique is applicable for both plates and pipes, primarily intended for pipe diameter of 1 millimeter and above, where access is permitted. The procedure is, after finished from film loading, start to perform this technique as visual inspection of the specimen, examine the welded specimen visually and note down any surface defects. Choose the appropriate IQI type according to the sample thickness of the same material as that of the specimen. IQI should be placed in a proper manner on specimen I.E source side and wires across the weld. Place the film underneath the plate. Place the lead letters. Set the source at right angle with the film and weld seam using magnetic stand. Set the specimen at a proper distance. It should be more than minimum distance that you can calculate it by the rule. Calculate the exposure time by application. Process the films inside the dark room. Second technique is panoramic. It should be performed for pipe of outside diameter from 12 inch. The procedure is, after finished from film loading, start to perform this technique as visual inspection of the specimen, examine the welded specimen visually and note down any surface defects. Use the appropriate IQI type according to the sample thickness of the same material as that of the specimen. IQI should be placed in a proper manner on specimen I.E source side and wires across the weld. Place the lead letters. Wrap the films around the welded pipe. Set the source at the center of the pipe using the magnetic stand.
Para nasa ano yun, nasa...
Calculate the exposure time by application. Process the films inside the dark room. The third technique is double wall single image. Should be used to radiographic pipes of 3.5-inch diameter and above when internal access is not permitted. The procedure is, after finished from film loading, start to perform this technique as visual inspection of the specimen, examine the welded specimen visually and note down any surface defects. Choose the appropriate IQI type according to the sample thickness of the same material as that of the specimen. IQI should be placed in a proper manner on specimen I.E source side and wires across the weld. Place letter F, which is mean film side. Because of the other technique is source side, wrap the films around the welded pipe. Place the source at an angle of 10 degrees far of the cap of the weld as you see. To take the film from inside. Calculate the exposure time by application. Process the films inside the dark room.
Kaya pala timing na tayo. Yan po, ang dami.
Fourth technique is double wall double image. It should be used for pipe has equal or less than 3.5 inch of diameter. The technique can be used in which the radiation passes through two walls.
Ayun ang comment ni
The procedure is,
online.
after finished from film loading, start to perform this technique as visual inspection of the specimen, examine the welded specimen visually and note down any surface defects. Choose the appropriate IQI type according to the sample thickness of the same material as that of the specimen. Source side and wires across the weld. Calculate the required geometrical unsharpness factors for both superimposed and elliptical techniques. Around the welded pipe. Set the source at right angle with the film and weld seam using the magnetic stand and be careful to place the specimen at a proper distance.
Ay. Huwag kayo makukulat kay Arvin.
Calculate the exposure time by application. Process the films inside the dark room. However, these techniques have a lot of applications and different guide in the detection of defects while compare them with each other. Because every technique has a special situation and limitations.
May pag-racing table pa yan si Orly.
Okay. Okay po, so hello po. So that's it po sa atin pong ultrasonic testing. Ultrasonic, sa ating pong radiographic testing. So, yeah, tapos na po tayo sa non-destructive testing po. Do you have any questions po? Meron po ba kayong tanong?
Wala po, ma'am.
Ma'am Julie!
Okay po, wala na pong kayo. Okay.
Okay.
So, bali, ang exam natin is sa Friday. Kailan na po schedule exam natin? Our schedule exam is on. Nakita niyo na po ba schedule ng exam natin? Hello po, hindi niyo pa nakikita yung schedule of the exam?
Wednesday po.
Kailan po? Wednesday. Wednesday nga pala. Wednesday, what time po?
Sorry.
11:30 to 1:30 po.
Okay po, yan. So Wednesday po, 11:30 to 1:30. So, kindly bring po pencil, eraser po, and ruler. Okay, and then I will announce din po if you need to bring po the cross-section paper. Okay, so our coverage po of the exam will be from Module 1 up to Module 4, Part 3. Okay? So there is a computations and terms po. 30 points for the computations and 70 points po for the terms. And okay? Do you have any questions?
Happy birthday!
Is there any questions po? Wala na po. So if wala na po, makiki-open po ako ng camera for the attendance. So pasensya na, medyo maingay po. Makiki-open po ako. Hello po, kindly open po your camera. Po, sino pong pwedeng mag-screenshot? Anyone po who can screenshot for the attendance? Anyone po? Hello? Okay po, sige po. Okay po, so if you have, if wala na po kayong tanong, you can leave po this meeting. Thank you so much po sa pag-attend and good luck po sa exam. Ingat po kayo.